Hello everyone. Today we will discuss about space contraction or Lorentz contraction in STR. So, space contraction. Sometimes it is called length contraction also. Space contraction. What is space contraction? What does it mean? Actually, it means if we see a rod of length L naught and in a situation, if we measure this rod length, then we will get this length is some fraction contracted or squeezed. That means it is not its proper length. So derive in STR space contraction. What is the situation for which this space contraction occurs? We'll discuss in this video. So at first, what is the condition? In STR, the condition is at first if we discuss for two reference frame. Let's say this is one reference frame. We call it okay, call it uh, X, Y, and Z, and this is called S frame, and this is called S prime frame, where this axis is X prime, this is Y prime, and this is Z prime. Now, the condition is if this S prime frame, this is S prime frame moving with velocity v, and if we take a rod, if we take a rod in this frame, so what will be the length for in S frame? If it has length L naught, then what will be the length in S frame? To discuss this, at first we have to take the endpoints. Let's say in S prime frame, these S endpoints are x1 prime and x2 prime. And this is for x1 frame also. This is x1 and this is x2. But mind it, this L naught is for S prime frame. We have to find the value of length for S frame. Here we will see the length is contracted. But why it is contracted? It seems to be contracted. But actually, we don't know. Because according to STR, the rod is moving with velocity which is comparable to light's velocity in free space. That's why this occurs. It seems to us this length contraction is occurring. So from Lorentz transformation equation, what did you know? From Lorentz transformation equation, from Lorentz transformation equation, we get to know x1 prime equals, let's say, this x1 plus dt whole into root over of 1 minus v square by c square. Let's say this color should be changed. This value will be some. I have taken it mistakenly. Let's rewrite this. So from Lorentz contraction rule, we get to know x1 prime. X1 prime equals x1 minus vt whole into gamma. Similarly, for x2 prime, we get to know x2 minus vt whole into gamma, where gamma has the value 1 by root over of 1 minus d square by c square. Now, in S prime frame, what is the length of the rod? In S prime frame, S prime frame, the length of the rod is x2 prime prime minus x1 prime equals L naught. We assumed it. The length is L naught in S prime frame. Now, if we put the values of x2 prime and x1 prime, what we will get? If we put the values x2 prime minus x1 prime equals L naught. Now, x2 prime equals, what is the x2 prime? x2 prime equals x2 minus vt whole into gamma. So, x2 minus vt whole into gamma minus x1 minus vt whole into gamma equals L naught. Now, x2 minus x1 minus t minus dt. Why I have taken this t is same? Because if we take t1 and t2, let's say this is t2 and this is t1, so it will give us t2 minus t1. Okay, that's fine. But if we want to measure a length of a body, we have to uh, measure it simultaneously. Its endpoints. Yeah, you got it. If we want to measure the length of a body, we have to measure the endpoints simultaneously. That means this T2 minus T1, T2 and T1 are same. So T2 minus T1 will be 0. Here I have taken T2 minus T2 equals T1 equals T. So, so uh, this will give us L naught by gamma. Then what is x2 minus x1? Sorry, x2 minus x1. x2 minus x1 and this value gives us 0. So I am not writing it. So L naught into root over of 1 minus d square upon c square. Now x2 minus x1. We took x2 prime minus x1 prime as L naught, which is the length of the rod in S prime frame. So we can say x2 minus x1 is the length of the rod with respect to S frame, and we take it, we take this length as L. So L equals L naught into root over of 1 minus b square by c square. Now, what is the value of 1 minus b square by c square? As you know, for free space, b is less than c, or it is comparable to c. So b is less than c. So b by c is less than 1. So 1 minus b square by c square, which is less than 1, which will give us a fractional number, and of course the root over of 1 minus b square by c square also give us less than 1 value, which is a fractional number. So some constant into fractional number will give us the less value than its proper value. I mean, if this this is our value of length, rod's length in S frame. So we can say, of course, it is less than its proper length L naught 1 minus b square by c square. That's why we call it. That's why we call it. That's why we call it. The length is contracted. Length is contracted. The length is contracted. That's why we length is contracted. So the length is contracted with respect to S, and is called this phenomenon is called the well-known space contraction or Lorentz contraction for a observer in S. So this is called this phenomenon is called space contraction or Lorentz contraction or the well-known length contraction. Okay, these are our target